Alright, this video is a recording for going through the WA2 practice paper. And I'll go through the MCQs first. Now, in the first question here, we have 4 statements about the structure of an atom, and you have to decide which one is the correct statement. Now, for this question, you have to know the various properties of your subatomic particles, namely your protons, neutrons, as well as your electrons. And for them, you have to know where's the location, you have to know what the number of protons actually mean, as well as the impact of the number of protons and the number of neutrons. And in this question, out of the 4 statements here, the only one that will be correct will be option C, which is the number of protons. You always determine the identity of the element. And that's why the answer is C for this first question. Now, for question number 2, you are given this table where there are 3 particles, X, Y, and Z. And in this particular table, you have got more information, such as the number of electrons, neutrons, as well as protons. Now, based on the table that you are given, you have to decide which of the 4 statements is the true statement. And if you look at them one by one, okay, you will notice how in particle X, the number of electrons and the number of protons are not the same. And this means that based on the number of electrons and protons, it means that X is an ion. It is a negative ion, in fact. Because the number of electrons is 2 more than that of the number of protons. Particle Y, on the other hand, it has 10 electrons and 9 protons. There's 1 extra electron. This means that Y is also a negative ion, but the charge of Y will be -1 instead of -2, as in the case of particle X. Then in the last particle, particle Z, the number of electrons and protons is the same. And this means that this is none other than an atom. It is not a positive or a negative ion. And another thing to take note of is the number of protons. You realize that particle X as well as particle Z are both of the same element. Okay, so look at the 4 statements now. X and Y are isotopes. And this is incorrect because they have different number of protons. For isotopes, you have to have the same number of protons. And option B, X and Y have the same charge. Okay, this is also incorrect, as we have already seen that the charges of the ions are different. Option C, X is a negative ion of Z. Okay, this is the true statement because you realize that they are both of the same element since they both have 8 protons. Okay, and option D, Y is a positive ion. This is incorrect because Y is a negative ion with a -1 charge. So option C is the answer for this question. Okay, moving on, in question number 3, which statement is true for the reaction between your sodium atoms and oxygen atoms? This is to do with your ionic bonding, and you have to understand how this ionic bonding actually occurs. And first, we look at the first element given, which is a metal. So metals such as sodium, okay, they will always lose their valence electrons to form positive ions. And on the other hand, oxygen, which is a non-metal, they will always gain electrons to form negative ions. So if you look through the 4 statements, you will realize that the only statement that is true, okay, will be option B, whereby sodium atoms, they will lose 1 electron each to form Na+ ions. Okay. Moving on to number 4, you're given 2 elements here, X as well as Y, and you're also given the electronic configuration of the elements. Now, based on the electronic configuration, you should be able to deduce that element X will form an ion of X2-. Element Y will form an ion of Y2-, Y2+, because of the 2 valence electrons. Now, on the other hand, you also realize that when we write our chemical formula, we always have to write the metal portion first. And therefore, I'm going to rearrange the ions here to have Y2 plus in front and Y2 plus in front as and X2 minus behind. And subsequently, the formula that you will get will be YX, because both of them have a charge of 2. Okay, and therefore, finally, when you bring the numbers down diagonally across, you will get a formula of YX, which is option C. So remember that when you have this particular case where the charges are of the same value, that means 2 plus and 2 minus, the values will, the formula can be simply can be further simplified into YX. Now, question number 5 shows the part of the periodic table. And first of all, always identify the metals that are on the left-hand side and the non-metals on the right-hand side. Now, once you have this idea here, you can look at the 4 statements to find out which of the statements is the incorrect statement. Let's go through them one by one. Now, W and X can form ionic bond, and this is true because W is a metal and X is a non-metal, which is true of the formation of ionic bonds. In statement B, W and Z will form a compound with a formula WZ. Okay, let's look at this. Now, W, because it is in group 2, it will form an ion of W2 plus. Z being in group 17, it will form an ion of Z1 minus. And the compound that you will get will be WZ2. That will be the formula of this particular compound. Which means that this option B is incorrect because the formula is not WZ but WZ2. Okay, let's continue and look at the other options to see why they are correct and therefore they're not the answers. Y and Z, if Y is in group 1, therefore it will form a charge of Y plus. Z is in group 17, again it will form Z minus, and therefore the formula that we will get in this case will be YZ, which means that it is true, it is correct. And finally, X and Z will form a compound by sharing electrons. This is again another true statement because they are both non-metals and therefore they will form covalent bonds through the sharing of electrons. So I hope that you are convinced that B is the answer now. Now let's look at number 6. Now you're given these two ions here, Fe3 plus as well as O2 minus. And if you were to bring using the method that was shared in class, can you bring the numbers down diagonally, you will get the formula Fe2O3, okay, which will be option D. Now, the other method that I shared, okay, was to do the hands method. So Fe3 plus will have 3 hands, O2 minus would have 2 hands, and you have to join the hands together. Okay, and this is something that we will have. So you can see that altogether, okay, you need quite a number of ions. Okay, and you will need 2 Fe ions as well as 3 of the oxygen ions. And that means that our formula will be Fe2O3. So option D is the answer. Now, number 7. And number 7 shows the full structural formula of water, number of shared electrons in a water molecule. Remember that always look at how many bonds are shown. Each single bond that is shown represents a total of 2 electrons. So if there are 2 single bonds here, the total number of shared electrons will be altogether 4 because there are 2 bonds. So remember, 1 bond means 2 electrons, 2 bonds means 4 electrons. Now, number 8 is a question whereby 4 properties, the properties of 4 substances are shown. So what would be a covalent compound? So let's recap. Okay, let's recap properties of covalent compounds. Number 1, they have low melting point and boiling point. Okay, number 2, they are insoluble in water but soluble in organic solvents. And number 3, they do not conduct electricity in any state. Okay, so I'm just going to write this briefly here and look through all the various properties, and you can, put ticks beside those that you think are possible as the answers, and you realize that the only option A is the answer because all the 4 ticks in that particular row are shown. So this is the strategy that you can use to answer such kinds of questions. Okay, let's move on to number 9. And in number 9, you have got 4 substances W, X, Y, and Z, and the properties are also shown here. This is mainly on electrical conductivity. So remember, the few things that can conduct electricity will be number 1, metals. All metals can conduct electricity. And number 2, ionic compounds can also conduct electricity, but only when they are in either molten or aqueous states. So if you look through the 4 substances W, X, Y, and Z, you realize that W, okay, it can conduct when in solid state. This means that this is a metal. X and Y are able to conduct electricity when in molten and aqueous states. These are ionic compounds. And finally, we have Z, which does not conduct in any state. That means this must be the last substance that we have learned, which is covalent compounds. So based on the conclusion that we have had, okay, look at the options given to you. You can go through one by one and you realize that W must be a metal. So I'm going to put a tick for the one that is a metal. And then you realize that now very clearly there's only one possible answer, which is B. But let's go through the rest. Okay, X and Y must be ionic compounds. So NaCl as well as KCl are examples of your ionic compounds. And for option Z, covalent substance here, and CO2 is a good example of a covalent substance. So for this question, you cannot just rely on your knowledge about the electrical conductivity. Okay, you also have to be familiar with the various examples of ionic compounds as well as covalent compounds. So please recap, go and revise chapter 4 as well as chapter 6. And finally, for number 10 for this section, it is on the balancing of equations. Look at this equation very carefully and then put in the numbers to balance this. Now, we have done this in class before, so it shouldn't be entirely new to you. And you realize that when you want to balance the oxygen, you realize on the left-hand side, there's 2 oxygen atoms. On the right-hand side, there's only 1. So put 2 in front of H2O. And then now you have got 4 hydrogen atoms on the right, but only 2 on the left. So place 2 in front of H2. And this means that P must be a value of 2. R must be a value of 2 as well. And Q will none other be 1. Therefore, answer is option D for Denmark for this question. So with that, okay, so this is section A. I hope that you have gotten the answers and you are able to understand the explanations given. All right.